Very good, great, excellent.
Excellent. Okay, let me start. And let me start, Martin, by thanking you very much for finding the time to come on here at the moment, because you must be exceptionally busy and exceptionally pleased with being shortlisted. And that's a shortlist of 5 out of about 800 quantum developers who first took on the challenge. Hello, Rohan, who took on the challenge of the Airbus Quantum Computing Challenge at the very prestigious challenge. And I was just wondering if you could tell us how it's all come about and what it means to Quantum South. Yeah, I'll just put you on mute. Hello, Rohan, you should be able. That's fine. Rohan, can you turn your speaker off, please? Let me, yeah, I'm surprised he can get, yeah, I think that's okay now. So, Martin, if you can answer that question.
Yeah, sure. The University of Montevideo has been interested in the quantum computing technologies. One of the IT directors in the university, Dr. Rafael Sotelo, is passionate about the Consumer Expo show in Las Vegas. And he has been meeting people from IBM, and he coordinated a workshop in the university, so just to promote the quantum computing technologies. That was last year, and that's where we made a confluence and brought the interest of the Airbus Quantum Computing Challenge that was launched in February 2019. And after that workshop, we discussed the problems that were proposed by Airbus. There was a multidisciplinary team excited about the nature of the problems. Some of them said, okay, these problems are kind of a thesis for a master degree or something like that, or even you can do some research for this. So we decided to pick up a problem related to cargo load optimization. That was probably a problem closer to us. Today, I was reviewing the Quantum Weekly magazine in UK, talking about the challenge, and that the first problem was not addressed by any team. That was just,
okay. Perhaps you could quickly tell us what the 5 problems were. Is that possible? Can you just quickly paraphrase what were because you could choose 1 out of 5 problems, couldn't you?
Yeah, one was the problem 5, that is the one that we addressed, just optimizing the load of an aircraft with some available containers in a limited capacity, with all restrictions of the plane, just to balance the plane, everything. So it's load with restrictions. That was the problem we addressed. We'll talk later about it. The first one, the one that was not addressed, was related to fuel optimization. When you have flights that are not long range, is like a flight of 3 to 4 hours, you spend a lot of fuel relatively to the entire journey. So it's very important how the airplane takes off. So there was an optimization of the direction of the path that the airplane is taking when taking off, just to save fuel at that moment.
Wow.
That was an interesting problem. We liked it, it had nice equations to solve, but looked like nobody addressed it. The other problems were related to other things in terms of wing design and other things related to dynamics of the flight with the air, and there were different equations to solve and things related to machine learning using quantum computing as well. So those were the problems addressed.
Okay, so with your problem, so you took the issue of the CFI, which at the moment runs, I think, in the industry. CFI, for everybody, is basically it's the efficiency of how you're packing in your cargo. So, you know, with the available space and all of the restrictions, and I believe that the industry standard is about 52 or 53%, which I thought was rather low. And you're confident that you can substantially increase that efficiency, which of course would lead to, I would have thought, a huge amount of savings in efficiency.
Well, actually, that number is the average of the industry, data that comes from IATA. But when you talk with experts and the top airlines, just to be profitable, you need to have a higher number. So we need to work with figures of 80%, 85, 90%. And this is where we need to work in the optimization. For sure, if an airline is operating at 50%, there is a lot of space for optimization, and that will work well. But probably when you work with top airlines, you will have to optimize on different levels that are 80% or above. This is what we have seen, for example, when working in some challenges in Southeast Asia. Yes. We have seen that. We have analyzed the landscape and how the itineraries are and how the airplanes are dispatched in one of the heaviest cargo airports in the world, like Hong Kong. And on the other side, in the North America reality, also talking with experts and the companies that operate in the region, and say, okay, you need to be at 80%. The problem is that the cargo is operating like behind the passengers' flights. There is the technology that it is currently used by passengers traffic is more advanced than cargo. So there is a digital gap there that is an opportunity for us. And this is where we can play an interesting role here in helping to improve that, because passenger load factor is today 81%, and you know that is digitally supported, strongly digitally supported.
Yes.
And the cargo load is having different things. They currently are operating with best practices for many things. They have software for optimization, a lot of things, but as you have a fixed itinerary, you are collecting orders from different customers, partners, and you fill the airplanes the better you can. So this is the current reality.
Yes, that's amazing. Can you explain to us roughly how the software works and the difference that quantum technology brings to your solution ahead of what is currently used in the industry?
Well, basically, we start with an optimization algorithm that we consider a particular input data, that is the configuration of the airplane with all the restrictions for the load and balance of the aircraft. So you have a capacity and a way to allocate those containers, this kind of load. And then you have what is really to be uploaded. And you decide what to be loaded with that algorithm. So the algorithm that runs in the quantum computer needs that data, configuration data, on how could be allocated, and what is the need to allocate. This data is sent to the quantum computing machine and then returns an output that is the actual proposition. That is what we expect to be better solution compared to the current environments. So this is plugged in the legacy systems. So what we need to do is to integrate this piece of software, quantum computing software, with the legacy system. So this is collecting all the orders that are coming, considering all the itineraries that are planned for the fleet, and come with a good alternative to optimize the load. And this would mean that, for example, if you have the same level of orders, meaning a particular level of revenue, what we can do is to deliver that with less cost. This is because probably we can use less airplanes, less flights, or just do something to reduce the cost. This is what we are expecting to be 1.6% if we could improve the load factor by 1%. But at the same time, if you keep the same capacity, you can sell more with the same cost. This is the other thing. So probably we can arrange the same fleet to deliver more goods, and the cost is the same. So that is where we can increase another margin when you sell more.
Yes, absolutely.
This is like this. You have the current operating landscape, you get the data, you transform the data, and you send it to the quantum machine. Similarly, when you work with some kind of data science or machine learning, that you prepare the data to send to the algorithms, and this is the way that we work.
Yes, absolutely. I mean, I can see that any increase in the CLF, the cargo load factor, is going to make a huge difference, whether it's in cost savings or increased revenue or just simple efficiency. It's amazing. I was interested when you were talking about the balance of the plane. Is there any safety aspect here?
The first safety aspect is that the plane needs to take off and arrive safely, because you cannot put the containers in any place. It is always a balance where you need to take care of what is in the middle, in the front, and in the rear part, and in the sides. So there is an increasing number of constraints that you need to consider. And it is important. Recently, we have heard in Europe of an airplane. It was a passenger airplane that it was not at full capacity, but the passengers were ordered with the wrong configuration for the airplane. Looks like they changed the model of the plane, but the configuration was run with another model. So there was no proper balance. Wow. And the airplane had a problem. So that's a reality. That's a reality. So sometimes when the passenger plane is not full, you need to distribute the passengers to balance the weight. So yes, this is what happened. So this is what could happen with cargo if you don't balance properly the load.
Absolutely. So that's another huge benefit, I would have thought. How different is a quantum solution for your typical plane or for a week's work of cargo? How different would your solution be to the main, I take it they're using mainframes at the moment to calculate the cargo. How much difference is there between a classical distribution of the cargo and a quantum distribution of the cargo?
Well, as I mentioned before, currently the process is being done with a lot of best practices that are operational practices that you feed the current load into the existing capacity. And then the operators are trying to fill the empty capacity in the airplanes just to improve the load factor. So there is a lot of manual work working there that perhaps you cannot do much if you don't have capacity. And the people is very busy with those scenarios. And there are cases for sure where the airplanes are full and you need to decide what things you should leave. But this is in a hurry, because if you look at the busiest airports, you have daily airplanes that you need to plan and optimize in all the things. So what we can do here first is from the algorithm perspective. So the optimization algorithm, if you run it in a conventional computer, will have some challenges because it's a complex equation addressed by engineering techniques like the research operation. You have algorithms like the knapsack problem, that is the one that we are addressing first, that it's not possible to run in a conventional computer in the entire dimension. So you need to work with a local optima. And this is the problem that you have with those kind of problems, that there are techniques that let you search local optimums because it is not possible to calculate the best solution because of the nature of the NP complete problems. So here, the quantum advantage is that these nature of problems can be addressed differently because of the nature of the quantum computing with the qubits that could be 1, 0, or both at the same time. So this is the advantage that the algorithms are having, and improves the order of magnitude of complexity of the algorithms. So that's the basic improvement that we have at the algorithm level, and the quantum computer can run a solution in a larger space, looking for spaces where the conventional computers cannot manage today.
Yes.
So this is what we are expecting now, because the size of the problems, the real problems, is currently not addressed by the existing quantum computers.
No.
So what we are doing now, and we are expecting to do it in the next 2-3 years, is to continue working on the algorithm, improving it, and trying to make it work for real problems in the available computers. So one thing is when we started 1.5 years ago with the IBM machine in the Qiskit environment, where we had limited number of qubits, less than 10 qubits to run our problem. But we were able to create the problem. So now, in 1 year, there was an incredible growth in the capacity. Not enough yet, but it was an incredible, it's like a race among the different providers. But yes, today, we are working with a larger size of problems. So, for example, with the D-Wave machine that is based on the quantum annealing techniques,
yes,
we are working with almost 50 qubits that let us work with a higher environment. But the current D-Wave machine is much larger, so what we are doing is improving the algorithm and adapting it to the D-Wave environment. and testing, and we are very happy because we did a huge progress with that. So next step would be to scale up to the larger computer, and this is a larger dimension of the problem. But that's it. And coming to some part of your question, we have different kind of quantum computer technologies that are coming here. So IBM is aiming to have a universal quantum computer. D-Wave is a particular set that is based on quantum annealing, and it's a very suitable machine for optimization problems that
Yes.
we think are the first one to be addressed. And it is the quadratic binary model, or quadratic unconstrained binary models. There is a particular set of equations that you can model, and if you can model a problem with those equations, you can run easily in these machines.
Excellent. Does your software favor quantum annealing or gate-based quantum computers? And if it's, well, if you could answer that question first, then we'll go into the different types of gate-based. But is there, would there be two versions of the software, one for annealing, one for gate-based?
Well, our idea is to have the software available for multiple platforms. So we are not thinking to have this tied to one platform. So after we created the first version of the algorithm based on the Qiskit machine, that is a universal quantum computer, that's the path of IBM, we said that we will try to replicate the concept in multiple platforms. Because one of the things that we had to do for the Airbus challenge was to review the current state of the art of the different machines and what will happen in the future. So we have analyzed what was the path for Rigetti, Google, Atos, Microsoft,
yes,
and D-Wave. So these were the environments that we analyzed. So once we completed the solution and delivered, we continued working with that. We started to analyze other machines like the D-Wave one that currently working with the Ocean platform. We are able to have a different level of algorithm. And after that, Amazon delivered the AWS bracket where you can access the D-Wave machine and access for a small piece of time and a reasonable amount of money, access to the real quantum computer, so you can run it and test it for real. So it's not like that you will need an entire day to run this algorithm. It's just to collect the data, as I mentioned before, send it to the machine and get the results. So it's a limited portion of time for the configuration. The other thing is the Microsoft environment. Microsoft is having in the Azure Quantum, started to release in a limited version. You can create your code and run it. So currently in the University of Montevideo, we have arranged with Microsoft to access to the quantum platform. The University of Montevideo is the only university in Latin America partnering with Microsoft as part of the quantum network. And we are conducting today trainings for students and master candidates. We have 30 people attending the first batch of this course. So this is very interesting from the capability development perspective. And then you can subscribe to the Azure network and have your space. And currently, Microsoft is developing their own computer, but what will happen is that you can run the code that you do in Q# in the Microsoft environment and run it in the Honeywell machine, for example. So when we talk with Honeywell, they say, okay, we don't have necessarily a platform for you to develop. We can give you a QASM environment, that is the quantum assembler environment. But what you can do to test our machines is go to the Azure cloud, run it there, and compile for Honeywell machine. So that's an interesting way to test the Honeywell machines, that there is a different approach to the technology that is very interesting and promising. And the other thing that we are doing, exploring, is with the Cambridge Quantum Computing environment, TICE.
Yes.
TICE is another platform where you can code, and then you can generate code for different platforms. And these platforms are gate-based only. So you can run in an IBM machine, or you can run it in other platforms. So as we develop the product in these years, we need to test everything. So what can I say? The quantum annealing approach is suitable for any optimization algorithm. So it is an opportunity there, yes. But we want to test all the platforms as well. Because if a customer is having a quantum approach with some partner with something, we cannot say, okay, our algorithm runs in another computer. They can run in this computer or whatever. So that should not be a problem.
No, I think you're quite right. You have to make it platform independent. I'm certainly interested in Microsoft's solution because, of course, they're running it on the topological qubit, as opposed to Honeywell, who's ion trap, and then IBM, who's a superconductive. So it's so interesting, that race. Now you've done an analysis of all of these different technologies, like I assume photonics, ion trap, topological, superconductive. Are you going to say which you think will be more important in the future, or which will win the race?
No. We have not entered in that analysis, and in our team, we can have different opinions. So we have
that's true.
Interesting internal discussions about it. So what we are doing now is to see, okay, we have the algorithm. We know how it runs in the simulator. We run it till what we can in the real quantum computer. Now we need to see what is the effect of the noise, for example.
Yes.
So we need to expose the different size of problems to the noise that is coming with the different computers. And probably in several months, we can have an analysis of the maturity of the algorithm compared to the noise that we'll have. So the coherence time and all these kind of things. So this is something that we will know in several months, and we can come with something related to the different environments.
Well, look, that's really interesting, because one of the biggest questions in the quantum computing sector is which technology is going to possibly, overshadow the others. And as you quite diplomatically and quite correctly say, everybody's sort of got their own opinion with that. So I think it's excellent. Do you envisage providing a quantum cloud service for smaller freight companies or any company that requires optimization? Do you see yourself as a applications provider on the quantum cloud when it comes here?
Yes, actually, the business model that we are working on is software as a service. It's like you yes. will have the service available in the cloud, and you just will send the data and get the result. And what we have to do is to create APIs in such a way that is very well integrated with the legacy systems. This is what we are aiming to do. So not necessarily you may have to have your quantum computer at home, but if you have it and you want it to run it, that should not be a problem, and we'll have our version for that.
Yes, absolutely. And I'm assuming that if it's maritime as opposed to air cargo, it doesn't really matter. You just need to get a database of parameters, and then you operate within that.
Well, actually, you will have a different configuration. The number of containers is different. The landscape that you have in the ship is different. So what we expect to do is to have the same nature of algorithms to do a selection of containers, but would be applied with different restrictions and way of working. But the nature is similar. So we are expecting that we can reuse that. And if we look at the nature of the equations, we are seeing applications in the financial service industry as well. So this is the other derivative that we have from our effort. And today we are looking at some use cases in the financial sector.
Yes, I see. Yeah, so tell us a bit more about the process that a large company, let's say a large company is watching this and wants to get involved. I assume there's a feasibility study, there's a testing. What is the process that you will engage with a large organization?
Well, currently, as we develop the products, what we are planning to do is to conduct consultancy engagement with companies, small engagements that will help the companies to define a roadmap of how they will adopt the solutions in the future. Quantum computers to solve problems like ours or others in their business. So just focusing, for example, in cargo, we can engage with a company and tell what is the current scenario in quantum computers, what is the problems that are being addressed today, how can be solved. So this is a basic introduction to quantum computing for technical people and business people. Then we will dig into the company problems. What could be the problems that could be addressed? Say, for example, the cargo optimization for a cargo company. We'll see how they are solving the problem today. What is the landscape? What are the airports that they are connecting? What is the fleet? What is the load? How it is coming? And how it's being processed today. So then we'll see. With the quantum algorithm, you can do this in this way and get these results, and you could operate at this level. So just to imagine how it would be the future with this new solution. Then what we can do is to do a small pilot or just proof of concept.
Yes.
With a small scenario for the particular company with a quantum computer that is available today. So we can do the exercise of saying, okay, we can optimize this with this quantum computer, and we can integrate this algorithm with your legacy systems and just see how it works. And after that, what we can do is to create a roadmap of adoption for the company to see, okay, in the next year, what you need to do to prepare to work with this new technology, and not only from the technical perspective in terms of software and IT landscape, but also from the human resources perspective. How the people of the company needs to be trained to be able to manage this technology. And this is something this simple is a short engagement. What we are starting to talk with companies and see how we can implement it, because this will create a path for companies to get involved with quantum computing technologies in the future. We are doing this for cargo companies, but also for financial services companies.
Yes. Now, look, I know this is an impossible question, but if you had to, can you give us some indication of how long it would take for an organization to get up to speed, and also what sort of dollars do you think would be the, an investment to get a quantum solution for, you know, a normal cargo company, let's say?
Well, what I can say today is that the cost of the solution must be associated to the gains that you are getting, like any IT investment. So this is nothing magical. This is just a new technology with incredible capabilities, like other technologies we have seen in the past 20, 30, or 50 years, or the entire computing history. So the business here is, okay, we have a solution, and I run my business today with these results and these costs, and this solution must be having its return on investment. So that's what we are thinking. If that is not possible, the solution cannot be adopted. That's the reality.
I guess you don't know what that is until you spend 3 to 6 months working on the actual data from the organization.
But just imagine how was ERP adoption by companies.
Yes.
One thing was companies operating before the ERPs. And you can see now companies working with ERP systems. So you work at different efficiency levels,
yes,
because you have the new technology. But probably you will have to invest at the beginning implementing the ERP, spend some money that you will amortize in different years. So this is similar here. This is what could happen.
Yes, absolutely. And I think, I know that we're a bit biased because we love quantum computing, but I think that whenever we talk about quantum optimization, rather like quantum simulation, it's one of those areas where it's a no-brainer to use that term. I don't know whether you've heard that term, Martin, but it basically is obvious that a quantum solution is going to be better for that type of industry. Which brings me to another question. You mentioned financial institutions before. Can you give us a little bit of a background to what you're doing there? And are there any other industries that you see as candidates for quantum optimization?
Industries are many applications, but we decided to focus because you cannot solve all the problems. So why airline, maritime, and then financial? Because of the similarity of the equations. We are working around the same level of equations. So the first thing we look at in financial services is the portfolio asset allocation, how you can optimize a budget that you have in a particular portfolio alternatives. There is a common problem, but the problem currently has a roof in terms of computational time today. So we are talking with expert people, say, okay, where it is the limit. Okay, the limit is where you have some particular equations and particular number of variables that you need to solve that currently is not possible. So when you are talking about differential equations with 50 or more variables, then you start to have challenges. Okay, now with quantum computers, you can explore those equations with larger complexity.
Are you talking optimizing with, did you say 50 stocks at the moment? What's the ceiling at the moment for current software with the number of stocks in the portfolio that can be optimized? Because I think that's an area, as you're just saying, that when we have a quantum solution, you could have hundreds of stocks. Is that right?
No, definitely. But like in the cargo space, you have a lot of best practices today that lets you manage an optimization with different things. But there are a lot of best practices and well-known things on how to do these kind of things to address a large number of things. But actually, you are not exploring the space in detail. You are using, okay, my experience is that you have to do this. So this is the best practice. And with this best practice, you choose with this number of assets. That could be 1,000 assets, because you discard a lot of things. But here you will analyze the entire mathematical problem. So this will bring another opportunity to work there. But it is not easy. It is not easy. The space for financial services is crowded. There are many companies looking at that. So what we are doing today is to research the state of the art, whatever is being done today. We have started looking at the equations that we use it for cargo. We found the first differences in the reality, because, for example, one thing just to mention is that when you allocate the container in the aircraft, the container weight is the same. So if it is 100 kilograms, it is 100 kilograms, but the asset return has uncertainty. So you are expecting that asset to have a return of 10%. But actually, when you allocate it, you don't know if it will have 10%. It will have 10%, have more or less. So you need to adapt the algorithm to manage uncertainty. It's not exactly the same, but the nature is similar. But those small differences may be having an important impact. And we are reviewing what could be done there. There are some people that saying that perhaps we are 5 years ahead of having some practical solution with that. But we are looking with experts in different parts of the world, and we are teaming up with people, particularly in UK, where we have very good colleagues working together. And we are seeing, okay, the portfolio equation is pretty much the same. So no much innovation there. The problem is how you solve differently that equation. So there are different things to be done there. But the financial service industry also have other problems that could be addressed, and probably you have to look at different nature of equations or maths.
Yes, they have things like risk management and all sorts of different areas. So, yeah, and as you say, I think there are a number of quantum developers looking at that area quite naturally. But I agree with you. It in some ways, it's no good just replicating what's being done now a little faster. I think one has to add that X factor in thinking about utilizing the full quantum potential in the way you do that, software.
Currently, several problems in the financial sector are being addressed with artificial intelligence, with machine learning techniques, with current conventional systems, and are having increasing good results. So what is being explored today in quantum is with quantum artificial intelligence. So how you can use the quantum computers for artificial intelligence. That is something that for us is little far, so we have not entered yet in analyzing what could be the techniques for that.
Yes, I always tell people at the moment, whenever anybody says the letters AI, I always say, well, look, nowadays it's QAI, because quantum has to be a part of artificial intelligence moving forward. I think there's no doubt with that. Martin, can you talk a little bit about the timeline? I mean, when you do talk to people in the industry about quantum solutions, it always seems to be, let's just say, a fair way off. Fortunately, with things like NISC technology, it's even though the quantum computers aren't pure qubits at the moment, they're getting better and better, so that you can still, with proper error correction, you can still reduce the noise factor, and you can still do things thousands of times faster than is happening at the moment. But specifically with your software, when do you think, could you give us an indicator of the timeline that you expect at the moment?
We expect at least 3 years to release the commercial product as a platform as a service, software as a service, or on-premise solution. That's what we are expecting to have something that could solve a real problem with the quantum technology available at that moment, say 2023 or 2024. In the meantime, as I mentioned, we are starting with the consultancy engagement that will bring proof of concepts and pilots that will let companies to start touching the technology and see how they can use it. And we think that that is the way that companies should approach that. And this is something that we can do it right now. Analyze the problem and how we can address it with the technology and what could happen in the future. So that is the reality. And it is important that companies start to review this this year, next year, because you should not wait till everything is done. Because if you are an active competitor in the market, you need to adopt new technologies like you have been doing always. So that's why companies should look at this technology and create their roadmap at their pace in terms of adoption of this technology. It's like you see cloud adoption. We are talking about cloud computers more than 15 years.
Yes.
So you see that companies are adopting cloud computing gradually. Some are pure cloud, others not. So same thing here with this kind of thing. Same that happened with ERP, same that happens with the Internet of Things devices that still needs to explode. I mean, for those who have been working in technology, we have seen many things with this, and we need to take care about the new technologies and be aware of what is a hype and what is reality.
I think that's very good advice, Martin. I think that, as you say, large corporates and even your SMEs should be engaging with the pilot systems and the feasibility studies and the testing. The time is now to do that. So if they wanted to get in touch with you, how would they do that?
They can connect through our webpage and connect there and send us an email or complete a form. So that's the way that we can connect with us.
Excellent. And if I can extend my email and meetup group here, you can most certainly contact me and I'll get you in touch with Martin. But look, Martin, I'd like to thank you very much for that insight. It was excellent. If anybody does have any questions, if they can email it to the group. And Martin, we have, excuse me a second, Martin. Oh, thank you very much, Mr. Van. Yes, thank you indeed. And if you do have any questions, please email them to us and we will get an answer for you. But I'd like to thank you, Martin. I'd like to wish you the very best of luck. And I believe that the final winner of the Airbus Quantum Computer Challenge, is that being announced in December?
Yes, that will be announced in December. This is a journey from the moment that you get engaged with this, the moment you select a problem, the moment that you study, create software, and then decide to go to the market and create a startup from this. So that's the journey, and you need to enjoy the journey. So as once we deliver the solution, we said, no matter what is the result, we will continue working with this. So with this view and approach, we are continue working here. We are very happy to have created a an approach for the problem that has been relevant for the industry. We are very proud of it. We are very happy. And hopefully we'll continue working with the airlines and with Airbus in the future, just to bring our solutions to the market.
Absolutely excellent. Thank you again, Martin. And that concludes our interview and presentation for the evening. It's funny that Martin mentioned Ticket and Cambridge Quantum Computing, because I will be interviewing them next week. I'm not sure what day it is. Mark Jackson from Cambridge Quantum Computing will be talking on this channel, so you'll all get an invite to that. So thank you very much.
Perfect.
Thank you again, Martin, and we'll talk again soon.
Okay, a pleasure. Bye-bye.
Bye.